Today we're going to learn about parabolas, graphing and writing equations. A parabola is a set of points in the plane equidistant from a fixed point called the focus and a fixed line called the directrix. Now we've talked about parabolas before as functions. That was when we had y equals, and I'll write that formula for or equation for you. We had y equals ax squared plus bx plus c, where parabolas only open up or down. Now we're going to talk about parabolas that open up or down, but also parabolas that open left or right. The format of our equation is now a vertex format, where the vertex is hk. If the sign on the 4p is negative, it's going to open down, and if the sign is positive, it's going to open up. Then the equation opening left or right has the y term squared. So then you know that it's going to open left if the 4p is negative, and right if the 4p is positive. The p is also used to find the focus. The p value is the distance from the vertex to the focus in the same direction that the parabola opens. This number is also important because it is the width of our parabola from one branch to the other through the focus. So let's look at our first example and graph this parabola. So since x is squared, we know that our parabola is going to open either up or down. And since our 4p value is positive, the coefficient in front of our other variable, we know that it's going to open up. So first we want to identify the vertex. So we can, just like I did on circles, write our format of our general equation, x minus h squared equals 4p times y minus k. Again, only one of the variables is squared. So our vertex, we look here for the opposite. So the vertex is -4, -7. The x value always goes first, the y value second. So h is always first, k is always second. In order to find the focus, it's usually easiest to draw the picture, and you can look at the distance from the vertex. So let's plot our vertex on our graph. So we go over -4, and we plot our vertex at -4, -7. Now we need to find the focus, the directrix, and other points on our parabola. So to find the focus, we need to set our 12 equal to 4p. So if 12 equals 4p, then p equals 3. So our distance from our vertex to our focus is 3. Now we know that it opens up, so our focus is above our vertex 3 units. Our directrix is 3 units in the opposite direction. So we go down and we draw a line at y equals -10. So now let's make sure that we have identified our focus, which is at the point -4, -4, and we need to also write the equation of our our directrix, an equation of our directrix, which is y equals -10. So notice, if we have an x squared parabola, our directrix is y equals. Then to find other points on our graph, we know the width of our parabola is equal to our 4p. So the width of our parabola through the focus is 12. So at the focus, our parabola is symmetric, So I'm going to go halfway to the right 6 units and half of the 12 to the left, so 6 units in that direction. So we draw our 2 points, then we can sketch in our parabola. That wasn't good. Let's try that again. Much better. Let's go on to example 2. Notice in example 2, we have y squared. And if we have y squared, then our parabola is going to open up either left or right. Since our coefficient, our 4p value is negative, we know that this parabola is going to open to the left. So let's look at what our vertex is. Remember, y is always associated with k, and x is associated with h. And negative 16 is our 4p value. So our vertex will be at 1, negative 3. Our p, negative 16 equals 4p. So p is negative 4. So let's graph our vertex at 1, negative 3. Now we know it's going to open to the left, so we need to go 4 units to the left and graph our focus. We go 4 units to the right, and this is where our directrix will be. So again, notice if I have y squared, my directrix is a vertical line, so the equation of my directrix is x equals 5. The point of the focus, the coordinates, is negative 3, negative 3. So now we know that the width of our parabola is 16. That comes from the 4p value. And since it's symmetric, we know there are 8 units up and 8 units down. So our graph wasn't quite big enough to fit the bottom point. Since it was one off, I just sketched it in there. And we will sketch our parabola opening to the left. So here are all the major points you need to find in order to graph a parabola. Whether it's opening up or down, x is squared, or left or right, with y being squared. So now I'm going to pause the video. Now it's your turn. Please pause the video and try example 3. Look first at whether the parabola will open up or down, x is squared, or left or right, y is squared. So here's what your graph should look like for example 3. Please also now pause the video and graph example 4. On this graph, I noticed that the width of my parabola was going to be 20, so I went to a scale of 2 for each tick mark so that my parabola fit more easily on my graph grid. Now a couple things to remember as you are graphing parabolas. Look first is x squared or y squared. Remember, if x is squared, it's going to open up or down. If y is squared, it's going to open left or right. If x is squared and 4p is positive, it opens up. If 4p is negative, it will open down. If y is squared and 4p is positive, it'll open to the right. If 4p is negative, it opens to the left. Lastly, remember that the width of your parabola, how wide your parabola is equal to 4p. So if you have any questions on graphing parabolas, be sure to ask tomorrow in class.